In this video, I'll introduce you to working with the ST-Sim BurnP3 Plus SyncroSim package, an add-on package to the ST-Sim State and Transition package. It incorporates the fire simulation capabilities of the BurnP3 Plus package to ST-Sim. This video will assume some familiarity with the BurnP3 Plus package. For an introduction to the BurnP3 Plus package, please find the links to our video tutorial and Getting Started page in the description below. You'll also find links to an introduction to the SyncroSim modeling platform and to our ST-Sim documentation website, which also contains video tutorials. Over the course of this video, we will go over the package structure, review the installation and setup of the package, go over the library datasheets and the necessary inputs to run a successful model, and take a look at the outputs of a successful model run. First, let's start by looking at the general structure of the ST-Sim BurnP3 Plus package. Now, the ultimate role of this add-on package is to link the ST-Sim SyncroSim libraries to BurnP3 Plus libraries. So we start by adding the necessary initial inputs listed here into the ST-Sim model with the ST-Sim BurnP3 Plus add-on package enabled. This library simulates succession while incorporating fuel treatments and fire transitions. The output state class map or the fuel type map from the ST-Sim model is then used as an input to generate a map of fire probabilities in the BurnP3 Plus library. This library requires its own set of initial inputs listed here. BurnP3 Plus then simulates fire ignition and growth according to weather conditions. The output fire currents map is then used as a fire transition map for the ST-Sim library. This cycle repeats for every time step and iteration in the ST-Sim model. Now let's go ahead and open SyncroSim. I'll be walking you through the package installation and setup. So we'll need to install 4 packages to run an ST-Sim BurnP3 Plus model. We'll need the ST-Sim and BurnP3 Plus base packages, the BurnP3 Plus Cell to Fire add-on package, and the ST-Sim BurnP3 Plus add-on package. So first we want to check which of these packages are already installed. To do that, we'll go up here to File and then down to Packages. This is a list of the packages you already have installed in your SyncroSim. You can see I have the BurnP3 Plus and the ST-Sim base packages already installed, as well as the BurnP3 Plus Cell to Fire add-on package. But I don't have the ST-Sim BurnP3 Plus add-on package installed yet. To do that, I'll go down to Install and select it in this list of available packages, and then can select OK. Now, if you don't have MIDI Conda or Conda installed on your computer, you'll get a prompt to install it right now. You don't have to use Conda to operate this package. It is an option though. So if you do wish to use Conda, you can just keep the default selection here and click Continue. This will install Conda. The process may take a few minutes. Now, once Conda is installed, you'll get another prompt to create the Conda environment for the ST-Sim BurnP3 Plus add-on package. Now, again, Conda is optional, so if you don't want to use Conda, you can just opt out of this prompt right now. But I'll go ahead and select yes. Again, this process may take a few minutes. Once the package is installed, you'll find it in your installed package list right here. Now we're going to take a look at the ST-Sim BurnP3 Plus template library to get a sense of the inputs required for this package. To do that, we'll go back to File and then select New to create a new library. Then we select the ST-Sim base package and then the ST-Sim BurnP3 Plus template library right here. You can opt to change the file name and the folder location here. I'll just go ahead and change the name slightly. And once that's done, you can select OK. This will download the template library. Now, this is what a library looks like. It operates on 3 levels. First, you have the library level here. It's called ST-Sim BurnP3 Plus in this case. Within a library, we have a project called Definitions, and within the project, we have 3 scenarios, one with unlimited fuel treatment, one with a restricted 100 hectares per year of fuel treatment, and one with no fuel treatment whatsoever. And each of these scenarios can run independently. let's take a look at the necessary inputs to run a successful ST-Sim BurnP3 Plus model. Data needs to be entered at the library level, as well as the project and scenario level. First, let's open the library datasheets by double-clicking on the library name. In the Add-ons tab, we want to make sure that the add-on package has been turned on. The blue check mark here indicates that it is indeed turned on. In the processing datasheet, you can enable multiprocessing to shorten the runtime of your model. If you do opt to turn on multiprocessing, just make sure that the last option here, copy scenario inputs for each job, is turned on. Otherwise, it won't work. Lastly, in options, this is where you can opt to use Conda environments. You can turn on Conda by checking the box right here. If you decide not to use the Conda package manager, you'll need to install the R software as well as the Tidyverse, Terra, FS, and R SyncroSim R packages. Now, if we take a quick look at the project properties, then go under states, and then state class, this is where you'll specify the different vegetation types and corresponding IDs contained in your input raster. We'll take a look at this map later on. Now, under the Advanced tab, in the State Attribute Type datasheet, you'll also want to create a Fuel ID state attribute type to track fuel types. Just a reminder that state attribute values are a function of the vegetation or state class and age of a cell. Now let's take a look at the scenario level datasheets. This is where most of the data is entered. So if we start with the pipeline, here we want to specify that the add-on model, Prepare BurnP3 Plus Fire model, runs before the ST-Sim model. So this will populate data sheets in the ST-Sim model that will allow us to run the BurnP3 Plus library. Next, if we go to Run Control, here's where we tell the model to run spatially and specify how many time steps and iterations we want in our model. In our case, we have 5 time steps and 6 iterations. Next, in the Transition Pathways tab, this is where we create our succession model. If we go to the Transitions tab, we can see it more clearly. You'll see that we use a very simple model that only resets the age of the cell after either a fire or a fuel treatment transition type. Notice that the class stays the same. However, this column here indicates that fuel treatments can only be applied to cells that are at least 3 years of age. So this datasheet essentially dictates what happens to the age and class of the cell after a transition. Now in the Initial Conditions tab, under Spatial, this is where we input our initial maps. In this example library, we'll only be needing the primary stratum, the state class, and the age map. Let's take a look at what these look like in QGIS. So in this template library, we only have one primary stratum, which covers our study area here. Next, we have our state class raster, essentially representing the vegetation type for each cell in our study area. So right here, you see the legend. Lastly, we have our age raster. So this represents the initial age of the vegetation in our landscape. This raster, along with the state class raster, will supply the information we need to calculate the fuel type for each cell. Typically, we would acquire data on forest age through a forest inventory dataset. Now let's go back to SyncroSim. The Transitions Target tab is where you specify area limitations for your transitions. In this scenario, we're only allowing 100 hectares of fuel treatment per time step. Next, we have the output options. Go to Spatial. Make sure you opt in for SyncroSim to produce spatial outputs every time step for these 4 options. So state class, age, transitions, and in particular, state attribute. So this last output will be used as an input fuel raster in the BurnP3 Plus model. Now, if we go in advance and then go down to transition spatial multipliers, here we have the option to choose to specify which locations in our study area we want to apply our transition to. Note that we haven't specified burn areas. That's because those will be added in later by the BurnP3 Plus model. Let's take a quick look at what our fuel treatment map looks like in QGIS. So this raster is a binary raster, and only areas we are allowing fuel treatments are marked in pink right here. Now back in SyncroSim, if you go down to attribute and then state attribute values, here we specify how fuel type is defined as a function of state class and age. In this example, any cell aged less than 3 years old, so cells that have undergone fire or fuel treatment in the last 3 time steps, are given the non-fuel ID. After 3 time steps, these cells are assigned the fuel ID corresponding to their vegetation type or state class. Doing the transition this way allows the model to retain the original vegetation type present before a fire or fuel treatment. So this datasheet will be used to generate the fuel raster that is passed to the BurnP3 Plus model every time step. Lastly, we'll take a look at the ST-Sim BurnP3 Plus settings datasheet. This datasheet is specific to the add-on package. This is where you specify which BurnP3 Plus library you want to use here, as well as which scenario within that library to use if you have more than one. So if you don't specify the scenario ID here, the model will simply select the first scenario. You'll also need to identify which transition group represents fire and which state attribute represents fuel type. Now I have the BurnP3 Plus template library open here. I wanted to show you where the outputs from the ST-Sim library are going to come into play. So I'm just going to open the scenario properties and navigate to landscape maps. These are the input maps for the BurnP3 Plus library. But I want to note that the fuel map here will be replaced each time step by the state attribute raster generated by the ST-Sim library for each iteration and time step of the simulation. Now, if we navigate to general and down to data feeds, we can see all the other data sheets that are required inputs for BurnP3 Plus. For example, the daily weather data sheet has information like temperature, relative humidity, wind speed, and direction, all of which are important to create accurate fire simulations. And once all these data sheets have been filled out, we're ready to run our model. So we do this by selecting our desired scenario and then either clicking Run Scenario up here or right-clicking and selecting Run down here. Once we've run our model and receive a green check mark, like so, we're ready to take a look at our outputs and results. The results scenario will appear in the drop-down menu under the scenario you just run in the results folder. We'll start by looking at the results properties. So we can double click it. If we go back to the advanced tab and then the transition spatial multipliers, you'll see that the burn probability maps for each time step and iteration have indeed been added. Remember, these were not present in our model inputs. Now we'll take a look at the results in the form of charts and maps. If you've just finished running the model, the results will already have a check mark like this and be ready to view. Otherwise, all you need to do is right-click and select Add or Remove from Results. Now we can navigate to the Charts tab and select the Transitions chart. The first chart displays fire transitions, so what area size underwent fire transitions in each time step. Same principle applies to the fuel treatment chart below. What area underwent a fuel treatment at each time step? You can toggle between iterations up here to view alternative outcomes. Now, the bands surrounding the chart lines represent the maximum and minimum values across all iterations. Now we'll navigate to the Maps tab and double-click Fuel and Transitions. The first row represents fire, so areas marked in red are areas that had a fire occurrence during that time step. The middle row represents fuel treatments, so areas marked in black are areas that have had a fuel treatment. You can view the effects of both of these in the bottom row, which represents fuel ID. Now, you can see the legend for the fuel IDs on the left-hand side here. Now, if you recall, we set the model to reset the age of the cell and change the state attribute value to match the non-fuel ID after either a fire or a fuel treatment transition. Note that in the fuel ID map legend, non-fuel cells are marked in gray. We can clearly see here in the second time step that a big fire occurred and that an area that previously wasn't marked in gray is now gray. Now remember, those state attribute values were to reset to their original values after 2 time step. And we can see that happening quite clearly here that on the 4th time step, we no longer see that area marked in gray. I can zoom in a little bit for you to see that more clearly here. And just like the charts, we can toggle between iterations up here to view alternative outcomes for this model run. Thanks for watching.